Hey guys, welcome to lesson 1-5, where we're going to talk about angle relationships. Some of the things we're going to do in this lesson, we're going to identify and use some special pairs of angles that we're going to learn about. We're going to identify and work with perpendicular lines. And then I'm going to split this video into two. In the second video, which is the second part of this lesson, we're going to work on interpreting geometric diagrams. Very important that we be able to understand what we're seeing and what we can and cannot assume when we're looking at a geometric drawing. We've got some new vocabulary here, and all of these new terms: adjacent angles, linear pair, vertical angles, complementary angles, supplementary angles, and perpendicular. I've got some nice visuals for us to define these. Let's start with these guys right here. Adjacent angles are two angles that lie in the same plane and have a common vertex and a common side, but excuse me, but no common interior points. Okay, what does that mean? That is a mouthful. Well, let's just look at it visually. So we're talking two angles that lie in the same plane. So we're assuming that they're flat and they're not twisted like this. They're lying in the same plane as the paper. They have a common vertex. So you can see right there, they share a common vertex and they share a common side. So this ray here represents their common side, but they have no common interior points. What does that mean? Well, remember we defined the term interior in our last lesson. The interior of this angle I'm going to highlight in green, okay? And the interior of my other angle I'm going to highlight in blue. So you will see that they have no common interior points, okay? The interior of each of these angles contains distinct and separate spaces, okay? So here's another example. Angles 1 and 2 here are adjacent angles. The word adjacent, by the way, what does that mean? Adjacent, you can think of as meaning next to. Okay, that'll help you remember this. So these angles are next to each other, but it's not enough that they merely be next to each other. They also have to have all of these conditions. They share a vertex, a common side, and they don't have any interior points in common or overlapping. Okay, here we have the same condition. Angles 1 and 2 share a common vertex. They share a common side. And all of the interior points in angle 2 are unique to angle 2, and none of them lie in the interior of angle 1. They each have their own unique interior points. So here's some non-examples to help us understand where we might look at angles that are not adjacent. Here, angle 3 is not adjacent to angle ABC. Why not? They share a common vertex. They share a common side. Actually, their common side is over here. But that means that this angle ABC has some overlapping interior points with angle 3. You can see they have common interior points. So actually, angle 3 is like part of the space that angle ABC takes up. So this is not an example of an adjacent angle. And likewise over here, angles 3 and angle ABC, they do not even have a common vertex. They do not even have a common side. And they, even though they don't share any common interior points, they don't meet those other two conditions. So these angles are not adjacent. They're not next to each other. Okay. Next, we have linear pairs. A linear pair is a pair of adjacent angles with non-common sides that are opposite rays. What does that mean? Okay, so angles 1 and 2 here are adjacent. They share a vertex. They share a common side. They don't have any interior points in common. And their non-common sides, this ray and this ray, are opposite rays, which means that this angle here is 180 degrees. Okay, so what's significant about a linear pair is that they are they add up to 180 degrees. We're going to learn in one of the subsequent slides that means they are supplementary angles. Very significant. So if you know one, you actually know the other because you can subtract from 180. Here's a non-example. This is not a linear pair because you can see ADB and ADC. These non-common sides are not opposite rays. They do not form a straight line. By the way, the term linear pair, of course implies we have two of something. We do indeed have a pair of angles. And the term linear, line, implying a line, which means basically when you put them together, their non-common sides form a line. It's another good way to remember that term, linear pair. All right, probably my favorite are the vertical angles. Vertical angles are two non-adjacent angles formed by two intersecting lines. Okay, just draw any two lines and they will intersect to form two pairs of vertical angles. Angles 1 and 2 are a pair of vertical angles. They're non-adjacent, they're across from each other. They do not share a common side, even though they do share a common vertex. Likewise, angles 3 and angles 4 would form a pair of vertical angles. Okay, and what's really cool about vertical angles, oh, look at this, Legos. Awesome. I love Legos. Legos are great for demonstrating vertical angles because you'll see that no matter how I turn this, I end up with two pairs of vertical angles. And what's interesting is the vertical angles are always congruent to one another. That angle is always congruent to that angle, and that angle is always congruent to that angle. How can that be? As this one gets smaller, that one gets bigger. As this one gets smaller, that one gets bigger. And so they always maintain that balance. You can think of it like a pair of scissors too. So vertical angles will always be congruent. This is important because in geometry problems, when you recognize these principles, you have free information that you can use to solve a problem. So here's a non-example of vertical angles. You can see that even though AC looks like a straight line, BED is clearly not a straight line. Okay, and so we do not call, I'm going to call this 1 and 2. In this case, angles 1 and 2 are not vertical angles, okay, because they're not formed by two straight lines crossing each other, and they're not going to be congruent to one another. All right, let's take a look at some examples. All right, here, could we name an angle pair that satisfies the condition? Two angles that form a linear pair, okay? So we have a lot of straight lines, roads representing straight lines that go straight through. So we do have a lot of things to choose from here in order to find our linear pair. Remember, pair means we're looking for two angles, and linear means we're looking for a line. When you put them together, they should form a straight line. I could look at UR and say, can I find on this line a pair of angles that adds up? Okay. I could say that UIQ forms with QIR. Together, they form a linear pair. When you put them together, they form a straight line here. And you can see that they share a common vertex and they share a common side. So I would say angle UIQ and angle QIR. Now, are there others in this picture? Absolutely. I could say angle PIQ forms a linear pair with angle QIS. I end up with that line, that straight line on the back side of this linear pair. I could also say that QIR forms a linear pair with RIT. And there I end up with that straight line, right? I could also say RIS forms a linear pair with SIU, or I could say RIT forms a linear pair with TIU. All right, in this problem, they want us to name two adjacent angles whose sum is less than 90. Okay, so adjacent angles have to share a common vertex, a common side, and have no interior points in common. So we are looking at, if I tried 95 and 55, those are adjacent angles, but they add up to more than 90, obviously, if one of them is greater than 90. But what about, say, BAC and CAD? They share a common vertex, they share a common side, they do not overlap and have any interior points in common, and they add up to 85 degrees, which is less than 90. So I could say angle BAC and angle CAD. Good. Are there any other pairs here? Any other adjacent angles whose sum is less than 90? Could we also look over here? Notice the way these are drawn. We have vertical angles here and vertical angles here. So over on this side, we have the same condition. NAF, angle NAF, and angle FAE. Those are adjacent angles. They share a common vertex, they share a common side, they have no interior points in common, and they add up to 85 degrees, which is less than 90. Good. Here, could we name two acute vertical angles? Okay, so I see two pairs of acute vertical angles we could name. Remember, vertical angles are formed, they're like our Legos, right? They're formed when two straight lines cross, okay? And that's why we end up with that condition where the vertical angles are congruent. That's why we have this condition here, 30 and 30. So these guys are vertical angles because they're formed where CF and BE cross. So I could say angle BAC, right? That's this angle, BAC, and angle FAE. Now, is there another pair of acute vertical angles here? Not these guys are obtuse, right? But what about these guys? Line CF and DN cross to form these two vertical angles here. So I could also say angle CAD, right? CAD, and angle NAF. Those are two answers that would satisfy that condition, two acute vertical angles. All right, we're going to define some more of those vocabulary terms here in this key concept showing these angle pair relationships. As I already let the cat out of the bag, I already told you all vertical angles are congruent, okay? So that angle is always congruent to this angle. This angle is always congruent to that angle, no matter how I move or change that about. The vertical angles are always congruent to one another. You notice how they've marked this here. They've given one arc to angle ABC and DBE. They each have one arc indicating that they're congruent to one another. And angles ABD and CBE each get two arcs indicating that they are congruent to each other. Okay. Now, complementary angles. I don't know if you have heard this term before, but complementary angles are two angles with measures that have a sum of 90 degrees. They may be adjacent, as in this case, or they may be non-adjacent. Okay, I could have angles that have nothing to do with each other. They're far apart. But if together they add up to 90, then they're complementary. Okay? Likewise, we also have this term supplementary angles. These are two angles with measures that have a sum of 180 degrees. They may be adjacent, like this. We already talked about this condition. What's that called? They're a linear pair. Angles 3 and 4 are a linear pair, and all linear pairs are supplementary. But they may be non-adjacent, like these examples, angles P and Q here. Okay, even though P and Q are not adjacent, we still say they're supplementary because together they add up to 180 degrees. Good. All right, how do you keep these two straight? when I was in high school, I was always mixing these up. And I couldn't remember which one was complementary and which one was supplementary. So here's what I came up with. Complementary. Okay. Complementary. I'm just going to put a line right there. And I have 90 degrees. See that? That's a pretty easy, cheap mnemonic if you can make it work for you. All I do is write the word complementary and I draw a line. I can write the number 90 degrees right there. So I know complementary is 90 degrees and supplementary is the other one. That's how I remember them. I don't know, maybe you can come up with a better mnemonic than that. And then the last thing is something that we've already talked about, the fact that the angles in a linear pair are supplementary. Okay, and again, that should come as no surprise since they do in fact form a line, and a straight line has an angle of 180 degrees. Good. Let's try some examples. Oh my goodness, I love this problem. This is a good problem. Find the measures of two supplementary angles if the measure of one angle is 6 less than 5 times the measure of the other angle. What? Holy cow, that's a lot of words. And what does it all mean? Let's read that one more time. I want us to find the measures of two supplementary angles if the measure of one angle is 6 less than 5 times the measure of the other angle. Okay. How do you think we should start this? What's my mantra? When in doubt, sketch it out. Most of these problems, almost all the time, when you get a problem like this and you have no diagram, you have to supply the diagram. That's how it works. So we're looking for two supplementary angles. What's the easiest way to draw two supplementary angles? How about that? How about we just draw a linear pair? We know linear pairs are supplementary. Let's draw a linear pair. Okay, let's read it again. Find the measure of two supplementary angles if the measure of one angle is 6 less than 5 times the measure of the other angle. How about I call x the other angle? Call x the other angle. Let's read it again. The measure of one angle is 6 less than 5 times the measure of the other angle. If this is the other angle and it's x, could I come up with an expression that represents the measure of this angle? They're saying that this angle is 6 less than 5 times the measure of the other angle. That sounds like 5x minus 6. Good. Okay, there's our diagram. We have a linear pair. How do we solve for x? Can we find an equation here? And what we're doing here is we're just slowly building up more and more geometric concepts so that if you have the geometric concept here, you can pull the equation out. If you don't know the geometric concept here, there's no equation available to you to help you solve. The geometric concept that helps us is knowing that these are a linear pair. Together, they must add up to what? 180 degrees. And now, where's our equation? X plus 5x minus 6 must equal what? 180. Okay. If you try this without a sketch, it will hurt your brain. Okay. And you will cause yourself pain and agony and unnecessary wailing and gnashing of teeth. Okay, so don't do that. Just sketch it out. And once you sketch it out, the problem is just going to fall into place for you. X plus 5x minus 6 equals 180. I think I can combine some like terms. I get 6x minus 6 equals 180. Okay, and I can add 6 to both sides. And I get 6x equals 186. And if I divide both sides by 6, I think I get x equals 31. Okay. Did we answer the question? find the measures of two supplementary angles. It didn't ask for x. In fact, x wasn't even part of the problem. We assigned it. Okay, so it's very satisfying when you find x, but don't forget to follow up and answer the question. What is the measure of this angle? 31 degrees. Now I could say, if these angles are supplementary, all I have to do is subtract that from 180, and I get that this angle is 149 degrees. But of course, if you want to check your math, you may want to plug that 31 in here, and you could say 5 times 31 minus 6. Now 5 times 31 is going to give you 155, and when you subtract 6, you're going to get 149 degrees. Look at that. Okay, so you get a problem like this, make sure you start to sketch it out, okay? And notice I read it twice before I even started to sketch, and after I sketched, I read it again, I think I read this problem 5 times. Don't be afraid to read them more than once. All right, this is the last problem I'm going to do in the first part of this lesson, the first video in this lesson. And this would be a great place to pause the video if you want to try this yourself. In this question, they want us to find the measures of two complementary angles if one angle measures 9 degrees less than 8 times the measure of the other. Now this sounds a lot like that last problem we did. So hopefully you've got some strategies for tackling this. It's slightly different though, because this time we're talking about what type of angles? Complementary angles, not supplementary angles. If one angle measures 9 degrees less than 8 times the measure of the other, how about I sketch it out? Okay, let's start to draw it. What's the easiest way to draw complementary angles? Complementary angles form a right angle. They add up to 90 degrees, right? Remember, I can draw that line and put that in there. 90 degrees, complementary. So I know these two angles are going to add up to 90. And they want to know if one angle measures 9 degrees less than 8 times the measure of the other. Okay, so I'm going to go ahead and draw this angle right here. Or I should say draw this ray, which forms these two complementary angles. Okay, and they're telling me that one angle measures 9 degrees less than 8 times the measure of the other. The other angle I'm going to call x. So if this angle is x, can I come up with an expression for this angle? This angle is 9 degrees less than 8 times this angle. That sounds to me like 8x minus 9, right? Okay, so where's our equation this time? It's not something plus something equals 180. It's something plus something equals what? These angles are going to add up to 90 because they're complementary. So x plus 8x minus 9 is going to equal 90. Good. Combine my like terms here. I get 9x minus 9 equals 90. Okay. I'm going to add 9 to both sides. And I get 9x equals 99. And I'm going to divide both sides by 9. I'm going to get x equals 11. Can you guys still see that down there? Okay. Did I answer the question? No, they want the measures of the two angles. I've got one of them. This guy's 11 degrees. And if it is complementary to this angle, I could say 90 minus 11 leaves me with 79 degrees. We could plug it in, see if that works as well. We could test this. This should be 8 times 11 minus 9. That gives us 88 minus 9, which does in fact give us 79 degrees. Good. Okay. Don't forget to tune in to the second video. I broke this lesson up into 2 parts because it's a little long and there's a lot of really important stuff in the second part. So make sure you remember to watch that. We're going to talk about interpreting geometric diagrams. Thanks for watching, guys.